This lecture is going to talk about merges, unions, and how to create and modify tables using SQL. It roughly corresponds to chapters 3 through 5 in the Advanced Certification Prep Guide. We've already talked about merging, match merges, in the context of the data step. So way back a couple weeks ago, we had the merge command, and we merged two data sets by some variable, and sometimes we attach an n equals a or an n equals b to do a left join, right join, inner join, all those sorts of things. So to some extent, this lecture is a repeat of that lecture. I'm just teaching you how to do the same things that were covered in the lecture in SQL. The union part is somewhat new. There's no real union statement, no idea of a union in the data step, but you can get around that doing other things. Let's start out with merges. So I'm using almost the same examples as we had before. So before we had two data sets, 1 and 2, and both of these data sets have a customer ID as well as some other information. So in the case of data set 1, the other information is a variable x. In the case of data set 2, the new information is some variable y. Now what you're going to notice is that these two data sets have two records in common, or two variables, two customers in common. So they both have customers 1 and 2. However, data set 1 has a customer 3 that is not included in the second data set. Data set 2 has a customer 4 who is not included in the first data set. So I've read these in using a data step. It's probably easiest to read them in that way. Then let's run some SQL, and I'll just print all the records. So you'll see here we go with data set 1 and data set 2. Now when SQL does a merge, the merge is done a little differently than what you get in the data step. The end result can be the same if you want it to be, but it does something that the data step does not do. So whenever you do a merge, the first thing that it does is it does a Cartesian product of the two data sets. So a Cartesian product is it matches up every possible combination of rows in the two data sets in this case. So let's just take a look at this statement. Select star from 1, 2. All right, so 1, 2 means go form the Cartesian product of these two data sets. So let's see what you get when you run this Cartesian product. Now the labeling is exactly what you get in your list file, and to be honest with you, it's not very good. So the first two columns are really from the data set 1, and the second two columns are from the data set 2. The reason I criticize this is that there's two columns both called ID. This first ID is the ID from data set 1, the second one is the ID from data set 2. So at this stage, all we're doing is we're going to match up every possible row in 1 with every possible row in 2. So you're going to see 3 copies of that first observation coming from 1. The 3 copies correspond to the 3 rows in data set 2. Then ditto for the second row in data set 1, ditto for the third row in data set 1. All right, so in general, if you have, say, n rows in the first data set and m rows in the second data set, the Cartesian product will have m times n rows, which is a very big table with n and m are even moderately large. So that's a Cartesian product. Again, this is not the way a data step merge works. And so if you ever need a Cartesian product, SQL's the easiest way to get it. I don't, off the top of my head, it would be hard to do a Cartesian product in a data step. I suppose you might be able to do something with arrays, But if you want a Cartesian product, use SQL. Occasionally you want that. Okay, usually you don't want the Cartesian product. Instead you want either a left join, a right join, or an inner join, perhaps an outer join. So let's see how you do an inner join. So here's the inner join. Select star from 1, 2. So there's nothing new about those first 2 rows of this select statement. We're going to add a where clause though. And the where clause says keep only records where 1.id, so this column here in the Cartesian product is really 1.id. This column is 2.id. So keep only records where those 2 match up. You're going to see here the IDs match up, and then this row the IDs match up, and so those 2 show up. Okay. What about a left join or a right join? Just to remind ourselves, here are those 2 data sets. I pasted them up here. That would be just printing all the observations. So to do a left join, what a left join does is it says we're going to have whatever the left table is. So if I do from 1 left join 2, okay, 1 is the left table. What a left join says is I want 1 record for every row in the left table. So the result's going to have rows for customers 1, 2, and 3. All right, so we're going to do a left join 1, left join 2 on. Now you have to tell how to match those up. So 1.id must equal 2.id. So that's the syntax. Here's the result. So this would be the equivalent of having an in equals a statement on the data set 1, and then using an if a comment to keep only, or if a statement in a data step to keep only those records. So that's the left join. Now, there's one small problem with this. You've got 2 copies of this ID variable, and you probably don't want that. So let's keep only the ID from data set 1. So how do we do that? Well, I'm going to explicitly list the variables in the select statement. So if I select 1.id, this 1 dot refers to the ID from table 1, and then let's keep x and y, and you get a better looking table. How do you do a right join? Well, you just substitute right for left, and the rest of the syntax is the same. The only thing is, instead of keeping 1.id, why don't we keep 2.id, since the ID from the right table 2 is the one that's identifying the records. So here's the result. So you'll notice that x is missing here for customer 4, y is missing for customer 3 in that previous result. So those are left and right joins. Let's move on to full joins. So full joins just keep everything. So let's, how do we do a full join? Well, we're going to keep, I could have just said select star and that would have been fine, but I want to be really clear about where these IDs are coming from, so I've decided to be a little bit more explicit. Let's select 1.id, and I'm going to call it 1.id to make this real clear. Then we're going to pick 2.id and call it 2.id, and let's pick x and y. So again, if I'd said star, I would have gotten these same variables, but I wouldn't have had the 1 or 2 labels on theirs telling where the ID came from. How do you do a full join or an outer join? You do 1 full join 2 on. So it looks just like the left join or the right join, except you say full join in the from statement. And here's what you get. So that's what you would get if you just did a merge on 2 files in a data step, as you get the full outer join. Now there's a bit of an issue here. The problem that we have is that we have 2 IDs running around, and neither one of them is what we want, because you'll see that one ID doesn't have anything for customer 4, and the 2 ID doesn't have anything for customer 3. So that's not what we want. SAS realizes that this is an issue, and so they offer something called the coalesce function. So if you say coalesce 1.id and 2.id, these are the variables that are in your on statement where you're setting them equals. This is just going to combine them, and you get what you really want. which is an ID variable ranging from 1 through 4, and then x and y. So if you ever need to do a full join as opposed to a left join or right join, use the coalesce function with that. One other topic on the subject of joins, and that is table aliases. Now, often your table names will get pretty big, especially if they're descriptive. So if you give long names to your tables, that makes it easier to maintain your code because it's more readable. Problem is you got to type that long name all the time. So sometimes you want to assign an alias to the table name so you don't have to type that long table each time. Now in this case I called them 1 and 2, which is hardly a lot of typing, but let me illustrate this idea of an alias with this example. So let's select a.id, x and y. I'll talk about a in a second. Okay, where are we going to get this? Well, it's going to be from table 1, but I'm going to give table 1 an alias. Let's call table 1a. Then comma, table 2 as b. So now whenever I use b, that's an alias for table 2. So how do I want to do this? Well, I want to do this where a.id, so what this really means is 1.id equals b.id or 2.id. Now notice I kept a.id up here, which is really 1.id. So this is just an alias. There is no data set A. A is just pointing to the table 1. So if you have long table names, you want to use table aliases. In the previous lecture, we made an RFM data set. So we made that RFM data set last time, and you should go back to the like slide 11 or something in this packet. How would we merge this with the customer table from DMEF? Well, here's the way you're going to do this. If I saved that RFM data set as cur.rfm, we want to merge the DMEF.cust file, and we want to match wherever the customer IDs match up. I'm doing an inner join here, and for this data set, that's fine. Often you'd want to do a left join if you wanted to keep it consistent with the customer file, or maybe you want to do a right join if you want to have only records from the RFM file. In this case, I'm going to make sure I have data from both. Presumably, I'm going to be building a regression model where I need both the stuff from the cust file as well as the stuff from the RFM file, so it doesn't make any sense to keep records where only one of the two contribute. So that's how I would do this for that RFM DMEF1 example.